Okay, so we're going to continue. What I want to do now is show you a sine function graph that involves all three of the transformations that we talked about. All right, so our function is asking us to our problem is asking us to graph y is equal to -4 sine pi over 2x. And so we have all three things going on. We have the negative in front of the 4, which is going to cause the graph to flip. We have the 4 in front of the sine, which is going to cause the amplitude to change. And then we have the pi over 2 in front of the x, which is going to cause the period to change. All right, so if you have more than one thing involved and the period is one of those, you need to work on the period first because that's going to determine the tick marks that you're going to use. All right, so remember that the way that I'm going to do that is I'm going to start by taking whatever is in here and I'm going to put it in between 0 and 2 pi. So remember that we do that because our original sine graph starts at 0 and ends at 2 pi. And then our goal is to get x by itself in the middle of the problem. So we're going to need to get rid of that pi over 2. So I am going to divide, and it's going to look messy for a minute, pi over 2 from all three sides, or divide all three sides by pi over 2. Okay, so on the beginning, with the 0 on the top, it's still just going to be 0. In the middle, the pi over 2's are going to cancel. All right, and then we're going to do a keep change flip for the last part. So we're going to keep the 2 pi, we're going to change the division to multiplication, and we're going to flip the pi over 2, making it 2 over pi. All right, and so when we multiply, the pi's are going to cancel out, and we're just going to have a 4. All right, so remember that this tells you that your starting point is 0 and your ending point is 4, and you're going to have 5 tick marks total, so that means you have 3 in between. Now, we can divide that 4 by 4 and see that we count by ones, but really on this one, you can probably just look at it and say, oh, okay, the tick marks are equally spaced one at a time. Okay, so that's going to take care of the period. All right, so let's go ahead and get ready to draw our graph. All right, remember that your x-intercepts are at first, third, and fifth. So those points are done. Okay, so our point, let me go ahead and mark my y-axis here. So I'm going to go up to 4. And then down to -4. Okay, so our normal sine graph has a point at 1 right here. So let's think about how that point changes. So with the 4, it's going to cause the amplitude to pull up, and that point's going to go up here to 4. And then remember that you've got a negative, which is going to make the point completely flip to the bottom, and so the actual point is going to be down here at -4. All right, and I'm going to connect those two. All right, so on my 4th point, remember that the point is normally here at -1. Because we have a 4, it's going to bring it down to the 4. And because we have a negative, it's going to flip it up to the top. And so our point is actually going to sit up here. So I'm going to keep connecting, get it up there, and then come down. All right, so again, on this graph, you should be able to tell me that the period is 4. All right, so remember the period has changed. It's going to take getting all the way to 4 before we start repeating ourselves. All right, and I'm getting that from this number right here. And the amplitude is also going to be 4. That's the height of the graph from the x-axis. And so the height of the graph is also going to be 4. Okay, so that shows you an example where we do all three things at one time. So you should kind of expect that the majority of your problems are going to have more than one transformation in them. All right, so now let's talk just a second about the cosine function. So very, very similar. We did exactly the same thing in class. We did a table of values. We did the same 5 values. So we did 0, pi over 2, pi, 3 pi over 2, and 2 pi. We were running short on time at this point in class, so I just filled in the graph, or filled in the table. And then we went and we plotted those 5 points, making the graph that you see on the left. So we have the point 0, 1, we have the point pi over 2, 0, we have the point pi, -1, the point 3 pi over 2, 0, and the point 2 pi, 1. And then we connected and we had our graph of our cosine. All right, we talked about how the period of the cosine graph is still 2 pi, just like for the sine. That the amplitude of the graph is still 1, just like for the sine. So those two things are the same. But the x-intercepts are different. Okay, so remember on the sine graph, the x-intercepts were at the first, third, and fifth points. On the cosine graphs, the x-intercepts are at the second and the fourth points. Now, in terms of working a problem, it's going to be identical to what we did on the sine. So we only did one example of this in class. So we're going to do one example right here. So we've got y is equal to 2 cosine 5x. So I know that I'm going to have a change in the amplitude because of this 2. And I'm going to have a change in the period because of the 5. Remember that we do period changes first. So we're going to take that 5x, we're going to put it in between the 0 and the 2 pi. All right, remember your goal is to get x by itself in the middle, so we're going to need to divide all three parts by 5. All right, so we have 0 is less than x is less than 2 pi over 5. And so 2 pi over 5 is our ending point. 0 is our beginning point. And remember that we're going to have 3 tick marks in between, equally spaced. We have to figure out what that spacing is going to be. So we're going to take our distance, which is 2 pi over 5. We're going to divide by 4. So remember that dividing by 4, we're going to keep, change, and flip the 4 and multiply by 1/4. So we're going to have 2 pi over 20, which is going to reduce to pi over 10. And then we count it off. So 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. And remember that the only reason I write this last one down is just to check to make sure that 4 over 10 is actually equal to 2 over 5, which it is. If it's not, then you've made a mistake somewhere and you need to go back and find that mistake. All right, and so then we are ready to draw our cosine graph. We know that we have x-intercepts at the second and fourth point, so I can go ahead and mark those two off. We know that normally the graph starts at 1 right here and goes down, but because the amplitude number in front of the cosine is a 2, we're going to be starting higher and going down. We know that normally on our third point, we have a point here at the -1, but it's going to go a little lower because of the amplitude pull. And so our graph is going to come down, touch down at -2, and go back up. All right, so on this graph, if I were to ask you for the period, you would tell me 2 pi over 5. And if I ask you for the amplitude, you are going to tell me 2, because that is the distance from the x-axis to either the top or the bottom of the graph. Okay, so that covers what we did in class today. Hopefully that helps you catch up. We will continue on Tuesday in class working on the other 4 trig functions.